In this video, we will be continuing our series on exercises 1.6 of Mr. John Coburn's Precalculus textbook. We will be finishing all of the word problems, um, actually from number 71 all the way to number 85. That's what I can do for now. I might continue answering further problems, but that will be for another topic. So, let's start with number 71. You have to note though that in all these problems, the line of orientation will always be horizontal. But in the first place, what does the line of orientation mean in the context of this lesson? So, in a situation wherein usually we have right triangles, um, let's say this is a tree and this is where you are. And in this context, we have the angle of elevation here presented assuming that it's theta. This is the line of orientation. In terms of line of depression, let's try inverting a triangle like this. Say that this is where you are and you're actually on top of a building and you want to know the angle of depression in a specific object below where you stand. So let's say this is a car. You're standing on top of a compound building and you're looking at a specific car. So for angle of depression, it's basically this one. Assume that it's presented as beta and this is your line of orientation. As you can see, they're both horizontal. And there's also one thing that you have to know. This is a mistake that I initially made. If not for a group of friends who studied with me before our exam, I might have taught you something different, something that's different in the wrong way. I initially thought that this is the angle of depression, when in fact it's supposed to be this one, as whether it's angle of elevation or depression, it has to always be linked with a horizontal line, which would always be considered the line of orientation. So yeah, let's officially start with number 71. So, this word problem is about angle of elevation. For a person standing 100 meters from the center of the base of the Eiffel Tower, the angle of elevation to the top of the tower is 71.6 degrees. So let's make a right triangle illustrating the scenario in this word problem. So assume that this is the person and standing 100 meters from the center of the base of the Eiffel Tower, he must be at the ground floor, at the same elevation of where the ground floor of the Eiffel Tower is. So apologies for my drawing, but just assume that this is the Eiffel Tower and this is the ground, which would eventually present itself as the line of orientation. And angle of elevation to the top of the tower is 71.6 degrees. So coming from the person, from the perspective of the person, to the top of the Eiffel Tower, the angle of elevation is 71.6 degrees. And we see here a value 100 meters, which would appear to be the distance of the person from the base of the Eiffel Tower. So basically, this is going to be our adjacent side. Just assume that this is a straight line over here that would pose itself as the opposite side of this right triangle. So the question is, how tall is the Eiffel Tower? So what's missing is actually the opposite side, this one. In order to find that, we do have 3 choices to pick from. We have So, we have Ka, and we have Towa. So I hope you've already learned about these choices, and based on the circumstances in number 71, we will use, it's most best to use Towa, for the reason that we are given adjacent and we're missing the opposite side. So as you can see here, O and A, they mean opposite and adjacent respectively. So tangent theta, which would eventually be 71.6 degrees, would be equal to opposite side over adjacent. Our opposite is missing, but our adjacent is given, which is 100 meters. So let's just rewrite everything here. There you go. Multiply both sides with 100. There you go. And eventually, this is what you will get. Opposite side is equal to 100 tan times 71.6 degrees. I hope you have your scientific calculators with you, because it will play an integral part in solving these word problems. Also make sure that your scientific calculator is set in degrees. From what I know, scientific calculators under the brand of Casio, you just have to press shift and menu setup. Just find degree. Try to look for it. The specific instructions actually vary from specific calculators, from calculator to calculator. Anyways, now that you've set your calculator in degrees, you'll have to fill in these values there. What I got here is 300.61 meters. This is the height of the Eiffel Tower. I did some research and it appears that this answer is actually true. The height of the Eiffel Tower located in Paris is 300.6 meters, or basically 301 meters if you round it off to the nearest whole number. So, let's move on to number 72, angle of depression. So, person standing near the top of the Eiffel Tower. So let's just say he's actually, or the person is actually at the top of the Eiffel, and he or she notices correct some distance from the tower. Angle of depression from the person's eyes to the wreck is 32 degrees. So from angle of depression, of course, we need to illustrate our line of orientation and assume that this is our triangle. This is the most likely triangle that we'll be seeing in this situation. So let's say this is where the car wreck is. And the angle of depression is 32 degrees. What you want to know is that in a triangle, usually, most of the time, all of the time, this part is 90 degrees. So in this situation, if you want to look for the value of this one, which would be extremely essential in finding the answer to this question, you have to look for the value of this angle. It's simple, actually. You just subtract 90 and 32 together, you get 68, if I'm not mistaken. I'm sorry, this is 58. So yeah, based on number 71, the height of the Eiffel Tower is 300.61 meters. So we obviously know that value already. And so the question is, how far away is the accident from the base of the tower? So this is where the accident is, and this is where the base of the tower is. So you can conclude that this is the missing value. So I suppose that we're set to go. Again, we have to choose from 3 choices, SOHCAHTOA. And based on what we have right now, from this angle of 58 degrees, I'm sorry, I'll be back for a while. I apologize for that. I hope you could skip that clip, that specific part of this video. Anyways, let's proceed. We have the adjacent side, and our missing value is the opposite side of the right triangle. So the most suitable thing that we'll be using for this problem is TOA. Tangent 58 degrees is equal to opposite side over adjacent, which is 300.61 meters. So as usual, multiply both sides. You have to transfer all values to the other side and just leave the missing value to actually find the answer. It's basic algebra, actually. So you get something like this. By the way, if you're wondering why I don't really put the numerator at the other side, doesn't really matter. Don't make things too complicated. So opposite side is equal to 300.61 tangent 58. What we get is 481.08 meters. This is the distance of the Eiffel Tower from the car wreck or the car accident. Alright, so far so good. Let's move on to number 73. Angle of elevation. In 2001, tallest building in the world was the Petronas Tower 1 in Kuala Lumpur, Malaysia. For a person standing 25.9 feet from the base of the tower, the angle of elevation to the top of the tower is 89 degrees. So we're looking for the height of the Petronas Tower. So let's draw. Let's assume that this is what the Petronas Tower would look like. Simple rectangle. And so what we're given is person is standing 25.9 feet from the base of the tower. Alright, I think I'm getting this. Let's assume that this is a person right here, and distance of 25.9 feet refers to this one. The angle of elevation to the top of the tower is 89 degrees. Angle of elevation, of course, is supposed to link together with the line of orientation. So this is 89 degrees. We're looking for the height of the Petronas Tower, which is this side. This is the missing side. So since we have adjacent and opposite, we use TOA. So tangent 89 degrees is equal to the opposite side, which is the missing one, the value missing, and adjacent would be 25.9 feet. So as usual, multiply both sides with the denominator value. Get something like this. So opposite side, or in other words, the height of the Petronas Tower is 25.9 tangent 89 degrees. So the answer is 1,483.81 feet. Right. Let's move on to number 74. Person standing on the top of the Petronas Tower 1 looks across the city and pinpoints her residence. If the angle of depression from the person's eye, so first, maybe we have something like this. So let's say this is still the Petronas Tower. And the person is located at the top of the said building. The angle of depression. So let's draw a line of orientation over there and write something like this. This is 5 degrees and 90 minus 5 is 85 degrees. We know that the height of the Petronas Tower is 1,483.81 feet. So what we're looking for is the distance of the residence from the base of the Petronas Tower. So let's assume that this is the residence. This is the distance that we're looking for. Okay. So we'll mind about this later. First, you have to find the missing value. We still use TOA. So tangent 85 degrees is equal to the opposite side, which is the missing value, divided by 1,483.81 feet. Multiply both sides with 1,483.81. So cancel over here. Opposite is equal to, please do use your calculators right now. 1,483.81 tangent 85. So opposite side is equal to 16,960.03 feet. So this is actually one of its final answers, but what's being required in the question is the final answer in feet and in miles. So now we have to look for miles since we already have feet. Let's convert this value into miles. So 16,960.03 feet over 1, multiply it. We do have to acknowledge that 1 mile is equal to 5,280 feet. You should it is advised that you should know the values, how much feet there in 1 mile. So with that in mind, there's this strategy that is taught to you in grade 11 STEM. It's usually applicable to word problems in general mathematics and this lesson, which is under the subject of precalculus, as well as general chemistry. Basic conversion of units. So 1 mile is put over here and 5,280 feet is put over there. Why in that fashion? In order to cancel the unwanted terms. So what you have right now is 16,960.03 feet divided by 16,960.03 divided by 5,280. What would you get? The opposite side is also equal to 3.21 miles. So these are the two answers required for number 74. Right. Number 75. Crop duster's speed. While standing near the edge of a farmer's field, Johnny watches a crop duster dust the farmer's field for insect control. So let's just acknowledge that this is the illustration. The book itself. I'm sorry. The book itself has already made an illustration. So let's make use of it. Johnny attempts an estimate of using the angle of rotation, which is known to be theta. Wherever the angle of rotation is, it usually refers to the angle where the person is situated, person's eyes are situated. So, standing 50 feet from the corner, this is the 50 feet distance. The angle of rotation is 83 degrees, which is which could be considered as theta. And for this distance, distance that the crop duster goes through to do its job of dusting the farmer's field for insect control, it's blank feet per 2.35 seconds. We have to look for the value. That's what we're looking for here. So, we have to acknowledge that, the final answer is supposed to be in miles per hour. So, let's proceed. We'll be converting the values later. First, we need to find this. So, TOA, tangent 83 degrees is equal to, so opposite side, which is the missing value, is this one, divided by the adjacent, which is 50 feet. So opposite side is equal to 50 tan 83 degrees. Opposite side is equal to what? 50 tan 83 degrees. We get 407.22 feet. Now let's put the per 2.35 seconds over there. Now we can start converting it from feet per second to miles per hour. How? It's pretty basic actually. Just write this as a fraction. So 407.22 feet divided by 2.35 seconds. So 1 mile is equivalent to 5,280 feet. And for in a single hour, we have 3,600 seconds. So cancel the unwanted units. So as you can see, we only have mile and hour. So 407.22 divided by 2.35 seconds times 1 mile over 5280, 3,600 over 1. So we get 118.15 miles per hour. This is the speed of the crop duster in miles per hour in its specific distance. Yeah, that's it for number 75. Let's move on to number 76. It has the similar concept, but of course the dilemma is pretty different. The scene, the situation. So, while driving to the next gig, Josh and the boys get stuck in a line of cars at a railroad crossing as the gates go down. I could already say that the illustration for this word problem could actually vary, but as long as the important details are situated at places where they're supposed to be at, I don't see anything wrong with varying illustrations, as long as they present the same correct solution. So let's say this is let's say this is where Josh's car is at, and This is the traffic. This is the railroad track, the crossing. This is actually where the crossing is, over here. But this is the railroad tracks. So, as a sleek, speedy train approaches, Josh decides to pass the time, estimating its speed. He spots a large oak tree beside the track some distance away. So, if this is where the start of the track is, then the tree might be located here. And let's say this is where the train is. Apologies for my writing, for my drawing. Just imagine it's a train. And track some distance away figures angle of rotation from the crossing to tree is about 80 degrees. So from Josh's perspective, the angle of rotation is 80 degrees. So if their car is 60 feet from the crossing, this is where the crossing is located. You could say that this is the 60 feet distance. What we're looking for right now is how fast is the train moving at 3 miles per hour. So it takes the train 3 seconds to reach the tree. So this one is over 3 seconds, under the limit of 3 seconds. How fast was the train in feet initially? Eventually, we'll convert feet per second to miles per hour, as stated here. But for now, let's deal with finding the opposite side in feet first. So, adjacent, opposite, obviously it's TOA. So, tangent, 80 degrees, is equal to opposite side over 60 feet. Opposite side is equal to 60 tangent 80 degrees. So what will our answer be? $340.28 feet. That is the length of that's how fast the train went under 3 seconds from this location to this. But then that's not our final answer yet, as we're supposed to convert this to miles per hour. So 340.28 feet over over 3 seconds. So let's convert them to miles per hour. 1 hour is 3,600 seconds, while for feet, 1 mile is 5,280 feet. Right. Cancel the units. So let's start multiplying. 340.28 over 3 times 3,600 over 1 times 1 mile over 5,280. What we get is 77.34 miles per hour. That's what you get for number 76. Let's move on to number 7. Okay. As for the height of a climber, local outdoors club has just hiked the southern rim of a large canyon. So this is the southern rim, and distance between sheer walls of the north-south faces approximately 175 yards. So the walls of the northern and southern faces of the canyon the distance is 175 yards. It's basically the length or the distance of the line of orientation. This is the northern rim, this is the southern rim. Using a homemade transit, they set an angle of depression to 55 degrees to the bottom of the north face. There's actually a mistake here from the book. The 55 degrees is supposed to be this one. It's angle of depression, so it has to connect with the line of orientation. So the angles of elevation of 24 and 30 degrees to the climbers and the top of the northern rim respectively. So 30 degrees refers to the top of the northern rim, 24 degrees refers to the location or where the climbers are specifically located at before reaching the top of the northern rim canyon. So question A, how high is the southern rim? So that's the missing value. Let's find letter A first. Southern rim height. We have 55 degrees. Technically, the height of this one is basically the southern rim of the canyon. They're equal. We get a triangle like this. And angle of depression is 55 degrees. What we're looking for is this one. So, TOA tangent 55 degrees is equal to opposite side over 175 yards. Opposite side is equal to 175 tangent of 55 degrees. So 175 times the tangent of 55 degrees is 249.93 yards. Yeah, that's the height of the southern rim. Alright, for letter B, how high is the northern rim? What we're looking for this time is the height of the northern rim. Based on the illustration, let's just assume that let the northern rim value, the height would be equal to, let's label this opposite to 1. This one is opposite to. There you go. So opposite to 1, we already have the value of that. For opposite to, let's solve for it. So we have a triangle like this. Still 175 yards over here. And the opposite side, which is this one, is a missing value. Okay, TOA, such that tangent 30 degrees is equal to the opposite over the adjacent. Opposite side is equal to 175 tangent 30 degrees. Let's see the value of that one. 175 tangent 30, we get 101.04 yards. Okay, so let's start adding. Opposite 1, which is 249.93 yards, plus opposite 2, which is 101.04 yards. You have to find the sum in order to get the height of the northern rim. The answer is basically 350.97 yards. Or, in estimation, it could already be considered 351 yards if you want to round it in the nearest whole number. Okay, let's solve for letter C. So how much farther until the climber reaches the top? This question is pretty specific. There has to be a reason why we have 24 degrees Celsius. 24 degrees angle of elevation. What we're looking for is this distance in specific. This one over here. How could we solve for that? Well, basically, it's opposite to minus, let's see, the 24 degrees value would be, assume it's opposite 3. So, opposite 2 minus opposite 3. Alright. We already know what opposite 2 is. And let's find opposite 3. We have a triangle like this, wherein this is 24 degrees. Still 175 yards here. And this is the opposite 3. TOA, tangent 24 degrees, is equal to the opposite 3 over 175 yards. Opposite 3 is 175 tangent 24 degrees. We get 77.92 yards. So, opposite 2 minus opposite 3 is equivalent to 23.12 yards. This is what we're looking for letter C. This measurement over here is 23.12 yards. Hang on, I need a few seconds. Alright, we can proceed now. I think I got confused quite a bit. Yeah, I'm pretty sure these are the answers. Right, let's move on to number 78. Actually, I'm thinking of making a separate video, starting from 78 to 85. But for now, I hope this video has helped you from numbers 71 to 77. I'll see you in the next video.